Okay, so today we're going to talk about using a protractor. Now, on the computer, using a protractor can be very difficult. So after this lesson, I did put a math playground game link in PLP, and I would suggest, spending 10 minutes playing around with it. But for a lot of this, and we're going to be able to use our reasoning to measure it. So even if you don't have a protractor, it's okay. We just have to remember what we know about angles. So protractors are tools that help us measure angles. Now, when we think about angles, we need to remember, just like what it says in here, a right angle is 90 degrees. That would be like if this ray kept going up here, it would have that perfect square. So acute angles, which are smaller than right angles, have to be less than 90 degrees. So I know that this is an acute angle. So this angle measure could not be more than 90 degrees. Obtuse angles are larger than 90 degrees, so I know that they have to measure that. So we can use our reasoning to help with a lot of it. This is what a protractor looks like. So a protractor is a tool, and when you measure angles, so if you have a protractor at home, you can measure the angles on your screen, and here's how you would do so. You would put that vertex, the point where the rays of the angle meet, you would put that vertex right here in the center. And then you see where you've got all these little lines and you've got numbers going up, and then on top you'd have the numbers going down. So this is where you have to use reasoning regardless if you have a protractor or not. Because if it's an acute angle and you measure it right here, you have to know if you're looking at the top number or the bottom number. But you'd put this on the vertex, and you'd put one of your rays on this bottom line, and you line up wherever your other ray fell. So if it fell on this line and it was an acute angle, you would know it would be between 50 and 60, and you could count 1, 2, 3, 4, that it would be 54 degrees. That math playground game is going to give you a chance to play around with a protractor online to help you understand that. So if we look at this angle that's on this protractor, we know, looking at the angle, that it is an acute angle. It is less than 90 degrees, which means I'm going to be looking at my top numbers. I'm going to be looking at my smaller numbers. If it is an acute angle, there is no way it could be between 130 and 140 degrees. It's not big enough. But I can tell that it's going to be between 40 and 50 degrees. So I'm going to count 41, 42, 43, 44, 45. I would say that that angle is a 45-degree angle. Okay, so on this one, this angle is an acute angle. That means it's less than 90 degrees. So on this side, I'm going to use my bottom number, because if it's acute, there's no way it could be 150 degrees. And this one, it looks like falls right on the 30 degrees. So that would be a 30-degree angle. So you can draw angles based on side measure or on angle measure. But here's one that we can look at. We know this is an obtuse angle. It is greater than 90 degrees. So I am going to be looking at my larger numbers for this one. It looks like it is exactly halfway between 130 and 140. So if I counted that, it'd be 131, 132, 133, 134. This angle is 135 degrees. Now, when you get down to your practice, you've got to use your reasoning. Here is the angle you're looking at. Before you look at anything else, decide, is this angle acute or is this angle obtuse? Well, this angle is acute, which means it has to be less than 90 degrees. So when I look at my options, only one of those is less than 90 degrees. So this angle must be 75 degrees. If you have a protractor at home, you can put that on it to check it, but we can use our reasoning. So then when we look at this angle, before I look at anything, I know that if it were a right angle, my ray would be here. It's over here, which lets me know it is much larger than a right angle. So it is an obtuse angle. So I know it's going to be greater than 90 degrees. Well, out of all of my options, only one of them is greater than 90 degrees. So you're going to do the same thing going down through them. You're going to use your reasoning to determine what the measure of these angles should be. And if you have a protractor, you can use that protractor to check yourself. I really encourage you to play this math playground game. It is Protractor Practice is what it's called. So when you go to it, it's going to be a link like your Generation Genius ones are links. You're going to copy and paste that link into a new tab. And here's the game. So when you start playing the game, it's loading. I'm going to start playing it. Now here's what's important. I know that this angle, it shows me that this angle is here. So I need to turn my protractor so that my red line is on one of my rays. So now I'm going to look. My red line's on my ray, so now I know it's an acute angle, so I'm going to be looking at my smaller numbers. I'm going to say 41, 42, 43. I'm going to say that that angle is right at 44 degrees. So I'm going to come over here, type 44, and it says the angle was actually 45. I guessed 44. As long as you're within 5 degrees, so you could have been in the 40 to 50 range and it would have been okay. Sometimes it's really hard to get it exactly precise. But then you're going to click the arrow and go again. The thing that's super important is remember to make sure that you rotate your protractor so that one of your rays, and you could rotate it the other way, you could rotate it so that that ray is on the red line, but one of them has to be on the red line.